Hello, and welcome to this section on I/O in C++. In this video, we'll be covering the basic architecture of the I/O stream library and introducing you to the classes that we will be using. C++ includes two input and output libraries, the old C-style I/O library and the new modern stream library. Since we are here to learn C++, we will be focusing on the stream-based I/O available in the C++ standard library. C++ uses the concept of streams to write and read data to external sinks and sources. I/O streams provide an incredibly flexible way to design the input and output routines of any program. The stream library is organized around abstract input and output devices. These abstract devices allow the same code to handle input and output to files, memory, or custom adapter devices that perform arbitrary operations like compression and encryption on the fly. You are already familiar with a few streams provided by the standard template library. They are the cout, cin, cerr, and clog streams. The general design of the input streams are like so. There exists some byte sequence at some source. That source could be the hard drive, the network card, or a keyboard. These devices are represented by a basic StreamBuff class, and that know how to interact with these devices. Then the iStream class is written to read the raw byte stream and format them into C++ data types. For output streams, it works in reverse. The OStream reads in formatted data and converts it into raw character streams. Then the buff stream outputs it to the device in an appropriate way. Once again, this could be any device, like a hard disk, a network connection, or your monitor. It all uses the same basic interface. All I/O is done through character streams. Those characters can be normal 8-bit wide characters or larger wchar_t characters, possibly 16 or 32 bits depending on your platform. Streams work with built-in data types. However, you can make your own user-defined types directly output to a stream by overloading the insertion and extraction operators. Here is the overview of how the I/O stream classes are structured. Some things that are good to keep in mind are that the I/O operations are type-safe and type-sensitive. They are also locale-sensitive, efficient, and interoperable with C-style standard I/O. They also include unformatted operators in case you need to get more granular with your program.